Our first LEGO League Robotics team, Vector 67, represents Virginia and Washington, D.C., where traffic congestion is the nation's second worst. On an average working weekday, D.C. area commuters spend over an hour on their way to and from work. From outer suburbs, that can be more like 2 hours. As we'll be showing you, most of that time comes from traffic congestion.
We all live in Northern Virginia where Route 7 and 267 and Interstate 66 are the main D.C. commuting corridors. Notice how the road network narrows closer to the city with fewer major highways. So many commuters going to the same place at the same time over the same roads leads to traffic congestion. That wastes time and resources and causes stress and pollution.
After brainstorming, doing some internet research, and talking with experts, we had a few traffic improvement ideas that we wanted to try. Since we're just kids and can't play with how traffic works in the real world, we created a traffic simulator. We'll show you 3 scenarios.
Scenario 1 is our proxy for the traffic congestion status quo. Red 2-person cars and green 20-person buses leave the suburbs and travel to the city. We're tracking simulation time and counting just the vehicles you see. We can also scale these numbers up to approximate DC commuting conditions. The rush lasts about 3 hours, and the average one-way commute is about 1 hour, much worse than the minimum commute, before congestion sets in.
Our first idea was to increase bus ridership. While Scenario 1 had 10% ridership, Scenario 2 increases that to 50%. More buses move the same number of people in less time, but traffic still backs up. The average commuting time improves, but not by as much as we'd like. Increasing bus ridership is a good idea, but it doesn't eliminate traffic congestion.
Traffic congestion is basically that backup of cars you've been seeing in the first 2 scenarios. Why does traffic back up? Because vehicles enter the road network faster than they can exit it. In Scenario 3, we reduce the network rate of vehicle entry to just the levels a city can absorb without backup. Rush hour is about the same as in Scenario 2, but the average commuting time is close to the minimum. Traffic congestion is gone. This looks like a smart move, but it's no longer what's smart for just one person, say, getting on the roadway early to be in the front of a line. It's what's smart for the whole community.
Okay, it's going to require some massively coordinated behavior changes to make the real world look like Scenario 3. Here are some ideas for that. In the long term, establish an electronic market where commuters can sign up for time slots on the bridges from Virginia into DC. Anybody who doesn't sign up but tries to line up by getting on the road anyway pays a discouragingly high penalty toll. In the near term, approximate market-based pricing with congestion pricing that reflects traffic levels predicted from experience.
Congestion pricing is already becoming part of DC area traffic policy. It's better than the status quo, but not as effective as market-based pricing. Electronic exchanges, global positioning, and mobile cellular apps provide the basic technology we need to implement market-based pricing. Starting to work on this now is the smart move.
This has been the Vector 67 Sign Up, Don't Line Up research project for FLL 2009-2010. For the latest information, please visit us on the World Wide Web at vector67.com.